Everybody, let's get this show rolling. Woo! Woo! So please give a warm round of applause to our two speakers, James and Bertin. Hope you're adding one more thing to my list of worrying about, which is hacking seismological networks. So please.
Okay, now can you hear me?
Yeah.
Oh, awesome. Okay, guys, welcome to our talk. This is called Exploiting and Attacking Seismological Networks Remotely. My name is Bertin. This is my colleague, James Jara. We are from Costa Rica. And we're here to share the results of our last research. So, okay, this is our disclaimer, first of all. This is not a typical talk. Of course, it's a technical talk. Probably it is the first research of this kind. All vulnerabilities that we found has been correctly reported to the US CERT, and they contact the vendor affected. We are not responsible of the action that someone can take after attending this talk. Okay. So, hello guys. Hello. Is starting up.
This is, okay, ready. So who we are. The agenda for today is this one. So who we already know. The motivation behind this research, how we get into these devices, how we find it. We will talk also about the risks and the impact, who is getting affected by attacking these devices. Also, we will talk a little bit about the seismological instrumentations in order to understand better this research. Also about the internals, deployments on the earth and ocean as well, about network topology, also how we get into vulnerabilities phase, also about the firmware analysis, attack vectors, and post-exploitation. And finally, we get into some conclusions.
And recommendations. Okay, so my name is Bertin. As I mentioned at the beginning, my colleague James, we are from Costa Rica, San Jose. We are the co-founders of the NetDB project, the Network Database project, which is a search engine for IoT devices. It's a project that I started 5 years ago, and then James joined into my idea, and we started working very hard from 2 years ago, and the framework and the tool. As I mentioned, we're from San Jose. Probably many of you know our country
Thanks.
because it's a nice place to live and visit. You are welcome anytime you want to visit us. We had a lot of beaches, not beaches. So you're welcome. It's a very nice place to live. We don't have army, so everything is pretty much cool and relaxed. Okay, the motivation for this talk, why are we interested in seismological networks? Well, an amateur attacker is not interested for attack these devices because we haven't seen a research previously in this field. It's pretty weird. Actually, if you take a look in the Snowden docs, if you look for the string seismological or seismic, Snowden doesn't mention anything about it, and that was pretty much interesting for me. Who could be interested? And I think that governments, in order to sabotage other countries' seismological networks. This is a new cool and attack scenario because these devices are placed in extreme environments, like in the middle of the ocean or in the underground, around volcanoes and specific areas. You're playing with devices that measure natural disasters, so it's very risky. This could lead to a financial sabotage to a specific company or country. The vendor of these instruments doesn't have any sense of computer security at all. I'm going to show you. Remote access, remote exploitation. So all the things that I mentioned power of this research to continue until today. Okay, how we discovered these devices?
So how we discover these devices? We have, as we told you before, IoT search engine. So let's see a demo about how we get into this device.
Okay, let me show you guys very quickly because it's not the main focus of the talk. This is the NetDB web GUI, or the web application. You can perform queries regarding our query builder tool. You can search in HTML, IP, ports, URL, HTTP headers, countries, SSL certificates as well, fingerprints, and so on. There are a lot of options. So in this particular, what happened here? Sorry. Okay, sorry. Okay. In this particular example, we are asking to NetDB for a specific IP address. We are indexing. Come on. We are indexing from this IP 3 ports, and this example LDAP SSL with the respective certificate, and HTTP server, and HTTP and the port 80. If you take a look at the same IP address, another search engine very well known for you as Shodan doesn't have any results.
Yep.
So I'm not saying that we are doing a better job scanning the internet, but we are doing something that they are not doing.
We are using another strategy to get into the results. So we are focusing on get many as data possible.
Yeah. Well, basically that is NetDB, and this is how we will be able to get into the seismograph. Just looking into the HTTP headers labels. Okay.
So as you can see, we have a lot of fingerprints of the many devices. So one day we have done a lot of research thanks to this search engine. We see a keyword, a very curious keyword. So we have another demo in which we will see how we get into this particular device. Okay, so
let's see the demo. So this is NetDB in action. As you can see, I'm asking NetDB for a particular string, which is Taurus. That string is available in the server label and the HTTP header of these two IP addresses. So you can see the fingerprint, JD 5.1x, Linux 2.4.24, NMX Taurus. That was pretty much new for us. And I noticed when you connect directly to the web server running in the port 80, you will get into this dashboard. And you are saying something very unusual. I have seen many researches about BNCs open in the internet and many other servers, but I haven't seen this before in my life. I have seen many servers, but this one was pretty much different because it's giving you readings, it's giving you voltage on readings, power, and waveforms. You can see how the waveforms, and there is an option called waveforms, and you can refresh these waveforms each 5 seconds. So at the beginning, I was not sure about exactly what was this thing. So for that reason, I started the research. Okay. For some strange reason, you find a unique fingerprint in millions of fingerprints that we have and we are currently collecting with NetDB in the public internet. So what is Taurus? That's the question now. So we have the web server, we have the readings, we have everything, we have access, and we can track them So we know already the fingerprints, so we can start tracking them on the internet. But what it is? Okay. What is Taurus? It's a portable digital seismograph developed by Nanometrics. It's a company based on Canada. And when you take a look in the official documentation, you will notice that it's pretty much connected to directly to the broadband seismometer, which is called Trillion 240. And then all the data coming from the broadband seismometer is routed to the portable digital seismograph and then the acquisition center. Also, it could be connected to a geophone. These geophones are devices that are placed in the middle of the oceans in order to understand better the sounds of the seismic waves in the middle of the ocean.
So, which is a seismometer? Seismometers are instruments that measure the motion of the ground. They are reading the wave movements from earthquakes, volcanic eruptions, or different sources. From Wikipedia, we read there are different common applications like earthquake detection, fracking, drilling, also mine safety, structural analysis.
So, continue with the research. So, we asked, so for example, which is the organization to keep the standards, protocols, and all the rules to get these devices properly working globally in the world. So I found the International Federation of Digital Seismograph Networks. This organization keeps up to date the SID reference manual, which is the standard protocol for earthquake information exchange and all the digital seismograph worldwide network. So these devices provide the real location, just connecting directly to the web server. As you can see, you can go to the timing option, and you will notice that the location area is providing to you the latitude and the longitude and altitude according to their exact location somewhere in the world. So there is a demo showing you how we were able to find a seismograph in the middle of the ocean. So let's take this data from this real production seismograph, and let's ask to Google for this location, and you will notice that it's placed in a very cool area. So let's go to Google, put the exact location, and hit it. And there you go. It's placed in the middle of the ocean in Europe, between UK, Norway, and Denmark. So we said, well, this is cool because this device is running in an autonomous way in the middle of the ocean. So let's attack this thing. So it's pretty cool because I haven't seen someone exploiting something in the middle of the ocean. So let's do it. You know. Okay, NetDB is giving us not their exact location because we are using the MaxMine databases in order to query the exact location of all IP address that we found every second. But it's pretty much accurate because it's telling us, well, your device is located in some ISP in the UK. So this is another example of how you can use Google Street View in order to query the same information. And we found this seismograph located in Marlow, Oklahoma. It's the same one here. This is the coordinates. And asking to Google, so it's telling us, well, it's inside that property. But Google Street View doesn't have access to property, so you are not be able to get into more inside the property, but it's in there. So it's pretty cool.
So which is the impact? I was looking for the real impact in the real world. So first of all, no one else has ever done, as we told before, research security about this field. So we know that we notice that we can perform a denial of service. Also, we can take advantage of the web server applications. Then we get into the web application vulnerabilities. We see that there are several bugs and information disclosure in the web application that is using, as we said, a Jara server. Also, there can be lead economic impact for oil and gas research of a specific company. There are other fields like a military industry and unknown areas.
Yeah. Okay. Another company which is called PGS, they sell these components or these networks in order to perform gas and oil recovery. So this catch my attention because you can see that there are a lot of applications for this technology, just not for earthquake detection or earth understanding. So vendors found in this research good old systems, Jewel Instruments, Jara, also there are other vendors, but the most affected is Nanometrics, which claims that they are the world leader in seismological instrument and networks. Also, you can take a look in Google for white papers regarding instrumentation and earthquake seismology in order to understand better how these devices works, because it's pretty much a science field. So it's not very familiar for us as security researchers. So it was pretty much difficult to me to understand exactly how these devices work. So I had to request some help to our organization in my country, which is called Obsicori, and they provide to me some information regarding how they work, and I explained to them exactly, well, I got a root shell here in this thing, so they told me, well, bro, we are screwed, basically. A lot of mathematics, a lot of physics. If you're interested, you can take a look. This is an example about other seismological instrumentation. This is an example about how to use geophones and what is the other one? Hydrophones in order to catch up the sounds from the ocean and to catch up the movements from the earth. But in the first example, they are producing a fake movement in order to get into the gas and oil. So I found a demo from a company doing this. And let's take a look how they are being deployed and how they are producing the fake movement in the earth in order to get into the gas and oil sources. So as you can see, each point represents a little sensor, but you notice that they have a big trucks and they in some way stimulate the earth in order to get the response and check, well, there is gas and oil, so let's dig into it. This truck is collecting all the data from the network and then is sent to the acquisition main center. So this is what we are attacking. Each of these little devices.
So let's take a look at how they looks at typical configurations. As we can see, we have the sensor and we have the portable digital seismograph. So basically, the portable is the small piece on the left top of the image. We have the broadband seismometer at the bottom, which is called Taurus. Which are the internals of these devices? They are Linux-based operating system. They have a remote management system. They have several services like SSH, Telnet, FTP, all the web servers, Jetty. They have a really accurate GPS that can be used in future to get, exactly location of the device. Also, they basically are made for ocean bottom deployment, in this case, the Trillium. They have a battery that can make the device be a long time, years in the ocean. In this case, we have a sophisticated image in which we can see a horizontal sensor, vertical sensor. We have accelerometers.
Accelerometers.
Yeah, sorry. Other layer for seismological and electronic stuff. In this image, this is a pretty expensive device, so we are not available to get one. So this is a HD photography in which we can see the several components of this device. What about the deployment options? We have two cases. The first one is for the air deployment, and the second one is for the ocean bottom deployment. For the first one, as a standalone deployment, it's typically running a buffer mode. It's not require a network connection. For the second one, it will work as a network element. So in this case, the user must configure the Taurus with the required acquisition server IP. So the Taurus will be streaming the data to the acquisition server using the MP protocol. That means Nanometrics protocol.
Okay, geophysics depend on seismometers to monitor earthquakes generated by the motion of the tectonic plates that form the earth crust. In order to function, the instrument needs to be leveled prior to operation. That's easy enough for a device deployed on dry land, but when it comes to seismometer placed in the ocean floor, thousands of feet below to the surface, the process gets a bit more challenging.
As you can see in the air deployment is pretty simple. It's a small device and it's simple steps to deployment. But now let's see a topology of the seismological network. Before jumping into the ocean deployment, this is how it looks a seismological network. In this scenario, we have three different communications type. The first one is a BSAT, the second one is a ADSL, and the third one is a GPRS modem. So basically, the data comes from the sensor, is sent by the Taurus to the acquisition server.
Well, this is a typical ocean bottom deployment. They're using autonomous underwater vehicles, as known as AUAVs. This is a pretty much expensive deployment because you need several ships and several UAVs. And each of these sensors and digital seismograph has a cost around $30,000 each. So it's pretty much expensive infrastructure. This is an example about how it looks like the dashboard, which receives all the data coming from the remote stations, in this case the seismograph. This is software provided also by Nanometrics, which is called Athena. And it can provide to you the exact location and a nice web GUI, but it's not the focus of the talk today. There is also an open source web server that can collect also the data coming from this station, which is called SysCom3. if you are interested to take a look in the open source seismological technology. Okay, the challenge, as I mentioned, is pretty much high. In order to function, these instruments need to be leveled prior to operation. It's not easy when it's 1,000 feet to the ocean floor. So I would like to share with you a video about how this works. Actually, we had sound.
Okay.
No sound. Well, this is a quick demo. Well, no, not a demo. It's just in order to take a look how these engineers works in the ocean deploying these devices. You can see this is the UAV, and that antenna that you can see is the GPS antenna. Inside that glass ball is the cylinder with the sensor. So these devices has an autonomy of 8 months. Also, they can be powered by a solar cell. Also, in some cases, they can be provided with a long-term battery because these devices consume pretty much few power for their operation. So there you go. This is going straight to the ocean. Okay.
Oh, that's you.
Okay, seismometers capture a transient phenomenon. If an instrument malfunctions, whether it is at the bottom of the ocean or at top of a polar ice cap, the data is lost forever. So it's telling us, okay, if you can deny of service this thing, you will lose a lot of data. And what happens if you do the same with 1,000 or 2,000 of these devices at the same time? So this could impact a lot the research that these engineers are doing. You need to be absolutely sure that the sensor will perform perfectly every time. That's exactly what the director of marketing of Nanometrics says.
So, what about the vulnerability research? We start looking for get a shell of the device. So we start looking first for the firmware in Google and other source. But what is pretty difficult to get it. So what I did was look with my friend for the firmware using other techniques. So let's explain about that.
Okay, so the firmware was not very easy to find in the internet when I started looking at it. So I decided to send an email directly to the support, the Nanometrics support, and they replied me back 10 minutes later, and they told me, welcome, you're welcome, Bertin, blah, blah, blah. So I'm going to give to you a username and a password in order to get all the documentation and all the firmware from us and all the software. Okay. So I said, well, pretty cool. And the same day, I started downloading and everything, the firmware and all the stuff available, because they gave me access. I haven't done anything illegal here or something weird. It just was a simple email requesting access to the firmware, and they were very gently to provide access to me to that database. Okay, so there's the firmware, finally. Is that TGC file, which contains a lot of scripts and batch. So basically, you don't need to use a Bingwalk tool or a finger mod kit in order to take a look into the firmware, like like other firmwares available in IoT devices. So I thought, well, you're kidding me, because there is a script called Taurus install.sh, which is pretty much a lot of bunch of batch commands. So imagine that you could inject a batch command inside that script and then upload it to the sensor, to the Taurus, and you will probably get a backdoor running always. So nothing complicated for us. Okay. After 3 days, they sent to me an email. Bertin, nanometric software and firmware can only be provided to registered customers, and I do not see your organization registered in our customer database. So what is the serial number of the Taurus you wish to upgrade? So they cut me up all the access to the database, but it was too late for them because I already have all the documentations and all the firmwares. So starting digging into the firmware, I was able to get all the passwords, the root passwords of the SSH daemon, the password of the web server, the password of the telnet, FTP, and everything. And also I found several backdoors that are not well documented in the official documentation. So, too much talk, I know. It's pretty hard for you. All this information, I know, is pretty heavy. So let's take a look in the demo. So this is the shell with the default password and the SSH daemon. So who I am, I'm root, of course. Let's ask to the system the uname, and you know it's NMX Taurus. And after that, what happened in the middle of the ocean is the following.
That's it.
Well, exploit. Let's take a look here again. So basically, now we have a root shell. We have the highest privilege on the system. We can do whatever we want. We have BusyBox shells also. We have access to all the system components, to all the threads, everything. Everything is completely compromised after you get the default password for the SSH server. So you can see there are a lot of profiles. So you can go straight to users txt template, and which are all the users in plain text. And you will notice that there is something called factory, which is not documented, and then central, tech, and user. The password is the same for all the users, central, tech, and user. And the factory backdoor, which is not in the official documentation.
These users are from the web application, specifically.
So let's continue taking a look into the system file. You get the PSW file. So let's do a cat. More users. You notice that the SSH password is not in here. It was in another file, but was only available unpacking the firmware. So the password was Dolphin 18 for the SSH server. I don't know why they choose that pretty much innocent password, I don't know, nothing related to the system or the field, Dolphin 18. So now we have access, user, a backdoor user, a lot of vulnerabilities. Let's test some vulnerabilities. I wouldn't call this a 0-day, but no one else previously found this bug before in the system until I reported to the US CERT. And actually Nanometrics confirms the issue, but they told me, well, yeah, the bug is in there, you win. But I think that there is no way to exploit this remotely, but it's in there, so well. I think that an attacker with a lot of creativity can exploit this remotely. So let's take a look in the video in order to show you how the bug works perfectly. Oh, pues. So let me rewind this. Okay, there you go. Also, you notice that we have access to all the interfaces. So we can turn off or turn on the interfaces. So this is the bug, the shell bug. It's completely vulnerable. And that's it. So more bugs and errors. You can see traces.
So here is an example about when we was trying to put it down the server Jara, we noticed that it's pretty easy to crash it out with just a fuzzing technique, sending randomly data over this Jara server because they don't have enough memory.
Yeah, you can actually send crafted URLs in order to get these traces. So
you will get a lot of disclosure information messages.
Okay. So another vendor affected that we notice is Guralp systems, specifically in the SSL protocol. These devices are running HTTPS server with full Herbig bug enabled. And also using our platform NetDB, you can query the SSL certificate for the string Gural systems, and you will get directly into the Gural seismometers.
So let's talk about protocol and communication stuff. These devices are using SEED. SEED is the protocol, the data format intended primarily for exchange of seismological time series data and related metadata. So the format of the nomenclature of the SEED formats use 4 components. The first one is the network code. It's 1 to 2 characters to identify the owner of the data. The second one is the station code. 1 to 5 characters for the station recording the data, because it could be several stations. Location ID identify the different data streams for a single station. And the last one, channel code, that is most important, will contain the band, sample rate, type, and orientation of the sensor. So if you want to know more about the SEED protocol, you can get into the reference manual that you can see on the web page.
Well, this is an example about Gural systems deploys the networking using a Scream server or something like that. Well, our attack now, we have a root shell, but we need to do something more. We are not just happy having a root shell and a seismograph in the middle of the ocean, so we need to do something else. So I thought, well, I have access to the protocol, I have access to the device, so let's do a man-in-the-middle attack from all the data coming from the Earth and being streamed directly to the acquisition center. So my position now would be in the middle of the station and the acquisition center, because these packets are not being sent using any type of encryption. There is no SSL, there is no PP tunnel, there is nothing. These these packets are being routed to the public internet without any protection. This is an example about how looks the packet header and the seismic packet. This is pretty much representative. It's not the exact packet. I did just for you in order to understand better how the packet looks like. Basically, it's an XML file which contains all the information regarding the latitude and longitude. And this is the main focus of the man-in-the-middle attack. Because we can modify in our proxy the latitude and the longitude, and this is going to be injected directly to the main acquisition center as a false data or false positive. So we can flood the acquisition center with false data. Let me show you the demo of the man-in-the-middle attack POC. Demo 6. So there's the same thing, the same seismograph in the middle of the ocean, but this time these devices has an option called communications. So they can stream in an autonomous way packets to any specific IP address that you provide to them. So let's take a look. Let's create a new profile in order to route all the traffic to my proxy. You need to go to data streaming. You will notice that there are some profiles in this seismograph. These three main profiles, but we're not going to touch anything. We're going to create a new one just for the proof of concept. Okay. So let's provide our IP address. And after press the apply button, this seismograph is going to start sending to me all the information coming from the Earth. And you will see at your right the TCP dump running. This is our proxy in this case. And you will see all the data coming straight to our proxy. And what I'm going to do is modify the latitude and longitude and then replace our IP address to the original main acquisition center IP address because it's using UDP. As you know, UDP packets doesn't use any sequence a mechanism like TCP. So you can spoof the IP address, and that's it. So, well, conclusions, we are able to locate these devices anywhere in the world. We are in control of the device, the network, and the software running on it. There is no SSL in communications. These devices help engineers to save people and understand the Earth. And vendors, please code better and think in security about devices that help us to protect our people and the world.
Yep.
So recommendations, basically, think in security when you code this equipment, and that's it. In case you have any questions, just let us know. Thanks.
Thanks.